Hello my dear viewers and welcome to one of our lessons. Today we will be talking about simplifying radicals, and we will do it with the numbers and also the expressions. Let's start with the numbers, then we go ahead and do it with the expressions. Let me give you an easy example. First, if we have square root of 25 and we would like to simplify this radical, all we have to do is we're going to have to do a vertical long division of 25, and we will always divide by the prime numbers, and the prime numbers, as all you know, is 2, 3, 5, 7, 11, 13, and so on. There are so many numbers, and the prime numbers only can be divisible by itself, and as well 1. Of course, any number can be divisible by 1. Okay, let's start with 25. So the smallest number we can divide with, or the prime number, is 5. So divide 5 is equal to 5. Then we divide by 5 again, equal 1. When you reach 1, you stop. And now the square root of 25, there is a 2 here, but we don't write it because it's a default. So we just write radical 25 or square root of 25. And we will take a group of 2 outside this radical. If we have a radical here, this number is inside, we call it inside, and a number out here, we call it outside. So this we will agree, me and you, for inside and outside. Okay, now we will take a group of 2. A group of 2 will take it as just 1, 5, and we will take it outside the radical, and there is no remainder, so 0 remainder, so we just cross it out, and your answer is 5. I know this is an easy example, but we will take another example also, still simple, and we will see what we are going to do. Let's try to find square root of 8. Square root of 8. So 8 can be divisible by a prime number is 2. So 8 divided 2 is 4. Divide 2 is 2. Divide 2 is 1. As we said, we reach 1, we stop. So we stop here. Then we will take a group of 2 outside and 1 left over inside. So it will be 2 radical or square root of 2. And this is your answer. Okay, now we will try to take a different numbers or different radical. If we have the index is 3, so we call it cubic root of, for example, 8, and also we will divide by prime numbers as we said. So 8 divide 2 is 4, divide 2 is 2, divide 2 is 1, and you stop. But here we will take each group of 3, so it is 1, 2, 3, so we take it as 2, and there is no remainder, so there is no radical left over, so all you're going to have to do is the answer is 2. Let's take a little bit harder one and see. If we need to find the cubic root of 120, for example, the easiest way is divide by the smallest prime number that you got. So 120 divide by 2 is 60, divide by 2 is 30, divide by 2 is 15, divide by 3, the smallest number, is 5, divide by 5 is 1. It doesn't matter if you divide by 3 or 5, but I would like to divide always by the smallest number to make it much easier. Anyway, now as we said before, we will take a group of 3. So here is 1, 2, 3. So we take 2 outside the radical. And what left over, 3 and 5. All we have to do is multiply it. It's 15. So outside the radical is 2 cubic root of 15. And this is your answer. Let's try another example. If we have the cubic root of negative 80, and as you know before, if you get square root of negative 4, this is imaginary answer, and we can say there is no solution for it, or you can just give it the imaginary answer, and we will talk about it in different video very soon. Okay, let's try to find the cubic root of negative 80. If you have any odd number in the index, you're going to have to just take the negative outside the radical. And let's do the 80 divide by 2. Smallest prime number is 40. Divide by 2 is 20. Divide by 2 is 10. Divide by 2 is 5. Divide by 5 is 1. And you stop when you reach 1. And now we will take a group of 3. Here is 1, 2, 3 as a 2. And this is left over. And as we know, we multiply together. So it will become 10. Or you just can take this number out here. But anyway, so this will become negative 2 cubic root of 10. And this is your answer. Let's try different one in different index. Cubic fourth root of, for example, 32. Let's see what we're gonna get. As you know, we will have to divide by prime numbers. So we get 32. Divide by 2 is 16. Divide by 2 is 8. Divide by 2 is 4. Divide by 2 is 2. Divide by 2 is 1. And now you will take a group of 4 as 1 and take it outside the radical sign. 1, 2, 3, 4. So here is 2 and remainder is 2. So you get 2 fourth root of 2. And this is your answer. And now we will try to see some expressions and we see how we simplify it. For example, if we have the square root of x power 5, y power 6, and z power 7. All you're going to have to do is, listen carefully, divide the power by the index, and we have 2 over here, and we agreed that we don't write it because it's a default. And we will see how much and how much remainder, the whole number and the remainder. Let me simplify this for you. So we will do 5 divide 2. 5 divide 2 is 2. 2 times 2 is 4. Then you subtract is 1. So your remainder is 1 because it's smaller than the divisor, which is 2. So all you're going to have to do is, this is the power out and this is the power in for x. So here is our square root. So we will write x power 2 out and x power 1 inside. We don't have to write 1, but I will write it just to remind you. Then we will do the same thing for 6. 6 divide 2 is 3 and no remainder. So we just put y power 3 and there is no y inside the radical because it's no remainder. Let's try this. The z has a power 7. So 7 divide 2. 7 divide 2 is 3 and remainder is 1. So we go z inside and outside. Z outside will take the power 3 and inside will take power 1. And let's write it professionally. It's x squared y power 3 z power 3 radical x z. And that's what you get for the simplified radical. Let's take another example with different index or different radicals. So if we got the cubic root of x power 5 y z power 9. As you know, we're going to have to divide the power with the index, which is 3. So 5, we do long division. I will remind you, 5 divide 3 is 1, 3. If you subtract is 2. So 2 is smaller than 3. So your remainder is 2. So you get x power 1 out. We don't have to write the 1 now. And x power 2 inside. And y, this is power 1 as we know. 1 over 3, this is a fraction already. If you get fraction, you just leave it inside. And the power inside is smaller than the index. So you get y. Now we do the z. 9 divide 3 is 3 and no remainder. So you get z power 3 out and there is no power inside. And this is your simplified answer. Let's try and do a different example with different radical index. The fourth root, for example, of 405, x power 7, y power 8, and z. Let's see how we're going to simplify this. As we said, we take the number with the long division, vertical division, 405. 4 plus 0 plus 5 is 9, is divisible by 3, so you can divide by 3. So divide by 3. Watch me how we do this. 4 divide 3 is 1 and remainder is 1. So you put the 1 here. So 10, and this becomes 10. 10 divide 3 is 3. 3 times 3 is 9, remainder also is 1. So you get 15 divide 3, which is 5. And now we will also divide by 3. Why we divide by 3? Because if you add the digits here, it's divisible by 3. 1 plus 3 is 4, plus 5 is 9. So divide by 3. 13 divided by 3, the closest one is 4 because it will give you 12 and remainder is 1. You add it here, so 15 is divide 3 is 5. Then divide 3 again because it's 9 over here. 4 divide 4 divide 3 is just 1. 1 times 3 is 3, remainder is 1, so you get 15 divide 3, which is 5. 15, all of you know it's divisible by 3 is 5, divide by 5 is just 1. And now we will write the answer for the number. And we said we will take a group of 4 because our index here is 4 and this is 3 and remainder is inside is 5. So you get 3 outside and you get 5 inside. Now we come to the variables, and the variable here is power 7 divide 4 is 1 and remainder is 3. So you get x outside and x power 3 inside. Now we will do the 8. 8 divide 4 is 2 and there is no remainder, so you get y power 2 outside and there is no y inside. Now z power 1 as a default, we said 1 divide 4 this is a fraction, so we just leave it inside. And this is your answer, and this is the simplified one. I hope that you enjoyed the video and learned something, and you can watch it over and over to see, because sometimes I speak too fast or you did not catch it, so you can watch it again and see if you can learn something. I would like to thank you again for watching and wish you the best. Bye.